So trig derivatives today. First thing we're going to do is graph our sine function. See if you remember how to do that. Ooh. Just the parent graph here. We'll just do the right side. Guys, what are the tick mark labels on the x-axis? Pi over something. Excellent start. What do we think? What's the first one, guys?
Pi over 2.
Pi over 2.
Like I said.
Pi over something, yeah. Then it's pi, 3 pi over 2, and 2 pi. If you guys are planning to take the optional summative assessment, remember all this stuff will be on there too, so start looking back through things. Okay, and is sine the graph that starts at 0, or does it start up at 1? 0. Okay, so here is your sine curve. Some rough sketch. Okay, I want you to try to sketch f prime of x based on the graph you were given. So think about what maxes and minimums tell you about your derivative, increasing, decreasing, all that stuff. Can you sketch f prime? Check in with your neighbor. You have no neighbors. Literally isolated in a corner. That's where. It's okay. All right, guys. So if we think about it, where our sine curve has a maximum or a minimum, what does that create on our derivative graph? Are we saying x-intercept? Mumbling? Okay. So I know I have an x-intercept at pi over 2 and at 3 pi over 2. And then, guys, remember, you're looking this first section of the graph. Everybody agree that's increasing? So what does that mean about my first derivative? Will it be above or below the x-axis? Above. Then where it's decreasing, where will it be? Below. And then increasing, it'll be above again. So hopefully you drew better than I did. Repeat. Let me fix it. So what does that graph look like? cosine. So the first derivative of sine is cosine. Kind of nifty, huh? All right, let's find the second derivative. So you can either think about the second derivative of the blue graph or the first derivative of the green graph. I do not care, whatever makes more sense in your head. Take a second there, see if you can sketch that. Check in. Does your sketch look like your neighbor's? So you can either be looking at the concavity of the blue graph or the increasing, decreasing max-min of the green graph. Either way will work. All right, put this one in purple. You can kind of see it. Is that what your graph looks like? Yeah? Okay. What is the equation of that graph? Andrew?
Minus sine x.
Yeah. Anybody questions? Like unsure of how I got the purple one? Yeah, sure. So, do you want to go from the green graph or from the blue graph? Green graph, okay. So maximum right here. So that's where I got the x-intercept from. And then, do you see how it's decreasing this whole section? So the purple graph has to be below the x-axis, and then minimum gives me x-intercept. Increasing, so I'm above the x-axis, to the next x-intercept because of the x. If you look at the blue graph, just to go over that part too, the change in concavity happens at those x-intercepts. And then this is concave down, so I'm below. Concave up, so I'm above. Okay, so whatever works in your brain. We're not going to graph and find the derivatives all graphically, because that gets a little interesting with tangent and secant and cosecant, all of that. So we're going to make a list of our trig derivatives here. Now, I'm not writing a full equation and finding dy dx, all of that. The way I'm going to note that I'm finding the derivative of a trig function is I'm going to say d dx, so just the derivative with respect to x of sine of x. Okay, we're just evaluating that little piece. So what would you tell me the derivative of sine is? Of sine. That one. Then what about d dx of cosine? What do we know that one to be? Yes. Okay, the rest I will give to you. So d dx tangent is secant squared. And we're going to find that one algebraically, but just jot it down. And d dx of cosecant is negative cosecant of x cotangent of x. I'll write them all and then I'll give you time to jot them down. D dx of secant of x that is secant x tangent x and then d dx for cotangent is negative cosecant squared of x. So you definitely want to know those 6. The sine and cosine ones are going to show up the most, but you do need to know all 6 of those. Any questions? Anything you can't read? We're okay. All right, let's try one then. Let's go ahead and find d dx of tangent. Let's show, we know what it equals, but let's prove that it equals that. All right, so what's another way I could write tangent? Yeah, sine of x over cosine of x. What rule do you think I'm going to have to use now? Quotient rule. Yeah, so guys, power, product, quotient, and chain rule, you're going to have to be able to apply all of those with the trig derivatives. Okay? So you start with denominator, which was cosine of x, times the derivative of the numerator. Well, what's the derivative of sine? Cosine, okay. Minus numerator, which was sine of x, times the derivative of the denominator. What's the derivative of cosine? Negative sine of x. Good. All over cosine squared x. Question? Okay, so that's just quotient rule. So we're going to simplify. What is cosine times cosine? And then minus sine of x times negative sine of x. All over cosine squared x. Should I cross out the cosine squared? No, thank you. All right, what is the numerator? What's cosine squared plus sine squared? What? It's just 1, right? Pythagorean identity. So I have 1 over cosine squared. And what is that? What's 1 over cosine, guys? Yeah, so secant squared. And that's what we wrote down for our derivative. So derivative of tangent is secant squared. Not really different than what we've been doing, other than you have to be able to find the derivatives of sine and cosine. But the mechanics are all the same as what we've been doing for a while now. All right, let's try another one. And stop me if you need more time, okay? All right, we're going to find dy dx. Your equation is y equals cosine of 5x. We're going to do this one together. Okay, when we wrote all of our derivatives up above, the trig derivatives, we just did like sine of x or cosine of x. We now have more than just an x inside our cosine here. That means we're going to have to use the chain rule, okay? So dy dx, finding the derivative. So start on the outside. What is the derivative of cosine? Okay, so we're going to have negative sine of 5x. You leave what's inside alone. And then what do you think I'm going to multiply all of that by? Close. Just 5, the derivative of the inside. Remember chain rule? You go through whatever power rule, anything like that, and then times the derivative of the inside. So we have to take this times 5. So your answer is just negative 5 sine of 5x. It's not hard. It's just easy to forget to take that last derivative of the inside piece. Questions there? Because I asked you to find dy dx. So we're starting with just, hey, you're taking the derivative. Like, what if it had just said y equals cosine of x, and I said find dy dx? Yes. So the only difference now is that instead of it being just an x in here, it was 5x, so you have that added piece of the derivative of the inside.
So how is the trig
You have to use the trig derivative on the outside. That's turning it into the negative sign part. Leave the inside alone, the 5x, and then take it times the derivative of that inside piece. Because think back when it, like, let's say it had been, you know, like x squared minus 5 cubed. Derivative of that, you do, in this case, the power rule, then times the derivative of the inside.
So you're treating it with sine of x, you just do the derivative of that, and you do also whatever is inside of it?
Yeah, like you could even think, okay, I'm gonna let u equal 5x. So now I've got the cosine of u that I'm finding the derivative of. So you would say negative sine of u, and then you'd have to do du dx, because we still need that derivative. We substitute it in for. So then when you plug that back in, you go, okay, well, u was 5x, and du dx is 5. Okay, so it's, you've got to look at those pieces. Like, it's almost like the sine or the cosine is like your parentheses. And then whatever's inside, you have to take the derivative. Instead of just power rule like we did on the right side here, cosine has its own derivative. Like, it's, think of it as like the trig derivative rules. You know, so you start with that, and then you take the derivative of the inside. Let's try another one and see if it makes sense, okay? All right, let's do y equals sine of 3x squared. You guys try this one. Find dy dx again. So I'll give you a minute here. Talk to each other. Are you there? You can move if you want to. You guys agree? Okay. All right, let's see. So we'd start with what is the derivative of sine? Cosine. Okay, so we've got cosine, leave what's inside alone, times what is the derivative of that inside piece? 6. Okay, so your answer is 6x cosine of 3x squared. Yes? Good? You're like, I can do it, I just don't really like why?
Yeah.
Okay, all right. Step 1, let's make sure you can do it. Anybody questions? All right, let's do, again, we're finding dy dx every time. Y equals 3x cubed times the sine of 2x. What do you see, guys? Product rule, yes. And it's this whole thing, this whole 3x cubed times the sine of 2x. There are the two things you're multiplying together. Take your time going through. It's going to take you a minute.
No, I was like, got the wrong coefficients, and I was like, oh, this can't be like 3 times 2.
Right, you're good on the calculus, you're good on product rule, but 3 times 2 is hard. Yep.
No, I seriously said 3 times 2 is 18. I don't know why that happened.
Well, there's a 3 times 3, which is 9 times 2, which is, you won't have all of that at once, though, so I don't know. You
Yeah.
okay. Just for fun. Yep. All right, guys, so I always like to do the second term first, so I'll do sine of 2x times the derivative of the 3x cubed, so I'm going to say times 9x squared plus that first term of 3x cubed times the derivative of the sine of 2x. So what's the derivative of sine? Cosine of 2x times what? 2, okay. So your answer should be 9x squared sine of 2x plus 6x cubed cosine of 2x. How'd we do, guys? Got it? Anybody troubles? Okay. We'll keep going. We've got 7 examples today, okay? All right, this one, y equals 2 sine of x plus 3 cosine of x. You are going to find y double prime plus y. Okay. It sounds worse than it is, I promise. Find the derivative, find the second derivative, add it to your original, and see what you get. Do you need to? So to use product or quotient rule, it would be 2 things multiplied, but they both have to have a variable. Okay? So it'd be kind of like if you had, 2x cubed, would you use the product rule for that?
No.
No. Okay, same idea here. Yeah, it's not that bad. It's really not. Bless you. Bless you. How are those allergies?
Yeah, perfect. I was like,
What did I do wrong?
Nothing.
You probably weren't expecting them to actually be able to combine at the end. It's kind of weird.
Oh.
All right, guys, what'd you get when you added them together? 0, yes. I'll go through it real quick, but it is 0. So I'll find y prime first. What's the derivative of sine? Cosine, so we're just going to have 2 cosine of x. What's the derivative of cosine? So this would be minus 3 sine of x. Not exactly the hardest derivative ever to find. Okay, then y double prime. Derivative of cosine is, so we have negative 2 sine of x. Derivative of sine is cosine. So y plus y double prime would be 0. Okay? Right. With polynomial derivatives, if you kept going first or second derivative, third derivative, eventually you'd get to 0 because you'd run out of exponents. But with the trig derivatives, because those functions just oscillate back and forth, derivatives are you just keep going around and around and around. Because you could do derivative of negative cosine, derivative of sine, it just keeps cycling through. So, a little different than your polynomials. All right, again, we're back now to find dy dx. Your equation is y equals cosine of x squared minus x. Are we ready? So what's the derivative of sine? Cosine. Leave the inside alone. All right, then we would be taking that times the derivative of the inside. What is that going to be? Okay. Now, depending on if it's multiple choice or what kind of question it is, you could leave it like this. You could also distribute and say this is 2x cosine of x squared minus x minus cosine of x squared minus x. Either of those would be acceptable answers. Okay? But again, just making sure, like, if it's multiple choice, that you can recognize that. Questions before we do your last example of the year? Feels weird. All right, guys. Y equals 4 cosine of x over 6. I want you to find the second derivative. Okay. This one will take you just a little longer. Guys, I'm going to work down just to the first derivative to make sure you guys are okay there. So if you have that wrong, the second derivative probably isn't going to go real well. Did you guys get negative 2/3 sine of x over 6 for your first derivative? Okay. Yeah, I'll give you a minute here and make sure you got the second one. Check with each other. Do you agree?
I thought you were writing the final answer, and I was like, that is not right.
No, I'm just going through it. So, what do we got? Negative 1/9. Does that make you feel better?
Yes.
All right, guys. Did we get negative 1/9 cosine of x over 6? Yes. Okay. Questions? Okay. Quizzes time then. Last notes for the year, guys. Feels weird. It should feel good. Yeah. No, it doesn't feel good. You don't want pre-calc honors to end.
No, I would like
Good. All right, guys, partner up. You can move if you want to. You don't have to just stay up here isolated by yourself. But if you're good with that, it's fine. Okay. Okay.